Alright everyone, or I should say future array. I'm going to go over this solution I created. It's a simple solution on how to memoize things. So you'll want to memoize things because, feel free to play this video at 1.5 times the speed because I pause a lot. Anyway, you'll want to memoize things because you don't want to calculate the value of something over and over and over again. So think of this as, say you have, say you want to cook pasta every day. And what do you need for pasta? You need the pasta itself and some tomato sauce. So what if, every time you had to cook pasta, you had to run to the grocery store. So you would make trips to the grocery store every single day. And that is just unnecessary, right? So we came up with this concept of having a pantry. A convenient location right next to the kitchen where you cook food. A convenient location where items that you normally use frequently are stored. So this is a concept of a cache, right? So if you have, say, and here's an excellent article that goes into detail about why you would want to use cache and how it's implemented and stuff. And I'll have links of this in the description below. Basically, you want to use cache to access frequently accessed things. Now, let's skip to the good part. The good part is I'm trying to solve this Hackerrank problem, and it's a simple problem, but I made it a little more complicated to get practice with memoization. The problem is, so they have an input like this one, JavaScript loops, and you have to go through this and print out the vowels one after the other. So in this case, you would print out A, and then go through, find the next vowel I, and then find the next vowel O, and that's it, right? After you've printed those out like so, you go through the loop again, and you print out the consonants. So you would print J, V, S, C, R until you reach S, right? So that's the problem. Now you could do a simple function. You could construct a simple function called isVowel. So let me just show you what that looks like. You could just say function isVowel, which takes an argument, a letter, right? And it just returns the operation, the value of the operation. It sees if S is equal to A or E or I or O or U. And if any of those are true, you see these are OR statements right here. If any of those are true, this whole function returns true. Now you could do it this way. This is a perfectly fine solution. But what if you didn't want to calculate this all the time? What if you wanted to store the values? Say you calculated it for A. You already calculated that A is a vowel. You don't want to calculate it again. The solution then is to store it. It's to store it in the form of a cache. So that's the implementation that is shown here. Let's forget about this part for now. Let's forget about this one. We'll come to it later. That's the main implementation. But let's take a look at how isVowel here is constructed. So here I declare isVowel to be something called an immediately invoked function expression. Now there are more details about immediately invoked function expression in the description below, but what it basically means is you define a function like so. For all you JavaScript people out there, you will recognize this as an anonymous function defined like so, and then you immediately call that function. You just immediately call that function, and whatever you get from calling that function, you assign it to the constant declaration isVowel. Okay. If people don't understand this, please leave me a comment, and I will get back to you. But moving on, let's take a look at what this does. This function. So this function takes no arguments. It is an anonymous function. What it does is when it's run, it creates an object, an empty object called cache, right? And it returns a callback function. Now, if you don't know what callback functions are, links in the description will point you to some amazing resources. It returns a callback function that takes an argument s, which is going to be used as a letter that we want to find if it's a vowel or not. So it returns a callback with an argument s. Now this is a crucial step here. In real life, this is going to be like, a or something. It's going to be the argument that is passed to isVowel. So we check if in the object cache there is a property called s, whatever that argument is. It could be a, it could be b, whatever it is. If there is a property like so, a true, like that, then it goes through the else. If there isn't such a thing, which in the beginning that's the case, what it does is it creates a variable called result and gives it the value of the this expression. This returns true if s is a vowel. And now it takes that result, whatever that is, true or false, and creates a new entry in cache for that s and assigns it the value of the result. So now if I had passed in isVowel of, say, a, in the beginning, the cache is empty. And so a would not be an entry there. And so an entry would be created with the value in cache a to be true, right? Now, let's look at this statement. If it so happens that s is in cache, this in keyword, I can link you an article that talks about that too. All it does is it checks whether this property is in this object. If it is in this object, it just returns whatever the value of that property is. Okay? So all we're doing is we're checking if there's already an entry in cache for that particular letter. If there is, we return the value of it. If there isn't, we calculate the value. Is it a vowel or not? We create a new entry in the object, and then we return that result. So the advantage of this is the cache gets filled up with values as you're calculating them. I'll show you what this looks like here. So let's look at this function. I won't go into this function in detail, but all it does is it takes a big string. So in this example, it's this big string JavaScript loops, right? And it goes through the string and does exactly what I said before. It goes through through the string once and checks if each of the entries, so first it's looking at J, checks if that's a vowel using our isVowel function. If it is, then it prints it out. If it isn't, it moves on. So A gets printed out, V doesn't get printed out because it's not a vowel, and then A gets printed out, and so on. So you pretty much get this. But the reason I created this whole video is to show you how these things get created. So let me just uncomment these lines so that you can see when the code is going into the cached result and the calculating result. You can really see the difference here. And just look at this output. This is the input passed in. Just look at this output. The first time, it had to check. It had to check for J. J over here. It had to calculate whether that's a vowel. And then it didn't print it out. And then it calculated for A. And then it did print it out because it was a vowel. And then it calculated for V, calculating result. It didn't, that's not a vowel, so it moved on. And then now we look at A again. This time, instead of calculating whether it's a vowel or not, it just fetched it from the cache. And it returned, yes, it is a vowel, true. And then it prints it out, and so on. So you can see here, over time, this really helps. The calculating result only displays about 12 times before every entry is pretty much in the cache. You see this? So in this particular example, I counted, and there's 12 times that the result is calculated. 19 times it was just fetched from the cache. Just think about how much of a performance improvement this would be if the calculating part was actually really complicated and involved a lot of calculation. You could just fetch things from the cache for things that are already calculated, so you could speed up performance. Anyway, I hope you found this video useful. I'll have the source code, the link to the source code, and other resources I used in the description below. And I hope to see you next time. Thanks.